Okay. Now let me go ahead. Arduino is a company, it's an open source company that designs and manufactures single board microcontrollers and microcontroller kits. So since it's an open source company, over time different people have gotten involved in the Arduino project, and they have led to designing better hardware software which can be used for implementing different kinds of ideas that people may have at projects. So now, before we move on, you may think that we are looking at different Arduino projects, but I don't have an Arduino since we require hardware for this. That's where simulation software comes in. We can simulate the Arduino board on different softwares, and we can actually see the way the Arduino works without having an actual piece of hardware. That's something you can do with modern computing, so I hope you're all excited with it. We'll be doing that shortly. So before I get started with the simulation, let me explain the Arduino Uno R3 board and pinouts, and if you have any doubts so far, please do let me know. Okay. So let me get started. So this is an Arduino Uno R3 development board, which I talked about earlier. It has the microcontroller built into it. So as far as peripherals are concerned, it has 14 input general purpose input-output pins, which is what GPIO means. So these they can be configured as we see shortly. In this analog section, we have pins where analog values can be given as inputs and taken as outputs. We have the power section, which involves VCC ground, which can be connected, and these pins here, these are digital input and output pins, which also support pulse width modulation, which we discussed earlier. Okay, so these are the general pinout of the Arduino. So these and there's nothing complicated here, and you'll understand more of it as we go along in case we have we actually using the Arduino shortly. So some basic commands will come back to this later, and we get started, which can be connected, and these pins here, these are digital input and output pins, which also support walk you through the process of signing into take a CAD and so on. These are the general. I've actually logged into CAD. So as you can see, so I'll just do this process here, and please do follow along. In case you have any doubts, so please let me know. Our moderators will also be helping you. Which you can just open a new browser window and Google Tinkercad, and hopefully you'll land upon the stage. So we're just walking through this sign up part here in case anyone has any problems, and you can go ahead and click into this. So please let me know. Our moderators will also be getting started. Which you can just open a browser window and Google Tinkercad, and hopefully you'll land upon the stage. So you'll land up on this kind of a home page if you have not already signed up or logged. And you can go ahead. So for people who are new to Tinkercad, you can go ahead and click sign up here, and you can go create a personal account. So you can create a personal account, and you can choose to sign up with your email or sign into Google or Apple. You may not be having an account, so for people who are signed up yet, as in but if you do know, if you have heard ahead, in fact, you can go ahead and sign. You can go create a personal. Otherwise, you can go back and create a personal account, and you can sign up with email or what I prefer. So over here, let me give you some time to do this process. You can go ahead and enter your region, and you can give birthday whatever your date of birth is. So over here, something like this, and you can go ahead and click next. So you'll be directed to a page where you have to sign up with your email, and you can go click into this and sign up with your email and click create account. I think that should be clear. For those of you who already do have an account, you can go The Arduino is just a development board with a microcontroller built in, and we'll be much more focused on using the microcontroller than studying about it. Main difference between analog and digital input output is the same as the difference between analog and digital signals. Analog input output peripherals are used to deal with analog signals, and digital input output pins deal with digital signals. So I hope you all were able to sign in without any problem. So is there any? So can I get started, guys? Can you all raise your hands if you're ready? So I hope you all. Yeah. Let me get started. So can I get started? Let me go ahead and get started with Tinkercad. So we'll get started with the most basic project, that is printing an LED. And yeah, let's go ahead. Yeah, let me get started. Okay, so for those of you who signed into Tinkercad, you can go into Create and create a circuit here. So I'm going to click into the Create button. You'll get a menu. Click into Circuit. You'll land up in this new page. We'll land up into this kind of interface. I hope you're all following along. So for those of you, then what you can do is you'll have this list of components here. You'll find different components on your right, which can then be, for example, if you want a DC motor, you can just drag it here. I'll not be using this just now, but yeah. Okay, so you have components here, and this, as you can see, can be used to start or stop the simulation. The most important part for us will be the code. Okay, so we'll get to this in a minute. You also have different types of views here, which we'll also cover shortly. So to blink an LED, what we need is an Arduino microcontroller. Let me go ahead and pull this up. And we also need an LED, obviously. So we get an LED. Now this LED is nice and red. Let me also get a resistor. I'll explain the reason for the resistor shortly. Pull this up. Let me go ahead and connect this resistor here. Okay, so now we have a basic setup with an LED, and these are the different pins of the addition, right? So as you all know, for this LED, this is the cathode and this is the anode, and cathode is grounded for an LED, as you all know. And let me go ahead and connect it to the ground. So this wire, generally we follow a color convention, and ground is generally taken to be black. So I'll make this wire black. Now this is a simple circuit, so it doesn't matter too much. But as we build larger circuits in this module, you'll find that the color coding really helps to keep track of which wire goes where. So when I advise that you stick with the color code, and now this wire, this is the anode of the LED. So I'll go ahead and connect it to say pin 5. And this wire, I'll change it to a different color since this is not the ground. Let's say green. So we have a setup in that. So now if I go into code, you can see that Tinkercad offers a mock interface, but now this is generally difficult to deal with as it's more meant for beginner-friendly applications. So go ahead and click into text and click continue. So you'll find this waiting right for you, and you can go ahead and clear the code which has been given directly by Tinkercad itself. So now this Arduino microcontroller uses C++ code, and it will slightly modified C++ code, and that's what we'll be using to link this LED, right? So let me go ahead and get started. So we have this code, microcontroller. We are supposed to use this void. We are supposed to begin with this void setup. So why is this? The setup of function. This is what initiates the program. This is called once the program starts, and this is used to communicate to the microcontroller and say, hey, the program has started. All right. And this loop of function, this is used to initiate a loop. This loop will keep running until we choose to end it. But in most cases, we choose to use this void loop. So this loop will keep running till it ends, and this is what we'll be using as the base to make the LED. So I expect some of you to be familiar with programming. If not, you can just follow along. So let me go ahead and define a variable LED. You'll see why I'm doing this shortly. And since I have connected to pin 5, let me make this 5. Alright. So within this setup box, I'll introduce you to the first function which we'll be using today. And yeah. So I have some basic commands displayed here, which is what we'll be using to blink this LED. This function, this is called pin mode off. So what is this pin mode off microcontroller? And say, hey, the program is here. As I've shown, you can see that it is used to configure a pin to behave as either an input or output. So you're telling the microcontroller that this pin is an input pin, or this pin is an output pin when you use pin mode off. So here we'll be treating this 5 as an output. Since we want the microcontroller to control pin 5, we want to make it high and then low, then high again in order for the LED to blink. So let me go ahead and make this output. Now here, the first parameter that this function will take is actually the pin number. So I can go ahead and put 5, and the program will still work. But I'll put LED because I want to make it much more uniform across. So if you want to change the connection from 5 to 6 due to space constraints, maintaining this variable up will allow us to do that without any problem. We can just make this 5 here, 6, and it will work just fine. I keep it as 5 for now. And I'll keep this as LED. This is generally a good idea in larger programs where you have to deal with the same number of pins. So defining this variable is just to make our lives easier. So you can actually put 5 here and the program will work fine. And I'll mark it as output. Now this output tells the microcontroller that that's an output. So far we have told the microcontroller what kind of a pin is an output pin. So now we want to make the output oscillate between high and low, and this is as a loop term. So here, let me introduce you to another function which is called digital write. So what does this digital write do? It's obvious from the name. It is used to write something onto a digital pin. As I told you, these are all, and I'll mark it as something. Right now this output tells the microcontroller that's an output. So far, it is used to write something onto a digital pin. As I told you, these are all, mark it as something. It is used to write something onto a digital pin. Sorry for that, guys. Not sure what happened. Yeah, we'll go ahead and play this quickly. So yeah. So we'll then need to introduce a delay and tell the microcontroller for what duration of time the pin is supposed to be high. Okay. So this delay function accepts the parameter which is in milliseconds. So if I put 1000 milliseconds, the delay is for 1 second. Right? So this indentation, it doesn't matter much. So you can go ahead and make this here and it will still work fine. But after that 1 second delay, what do? We have to make that pin go low so that the LED starts blinking. So you guessed it, it's digital write of LED, comma low. Yeah, forgot a semicolon here. So you can put that in, and the same process holds. Now we can change the delay if you need, and make it 1000, or 1500 if you want the LED to be off for slightly longer. Uh, I'm sorry. So if we go ahead, and so I'm just making the indentation uniform. So we can go ahead and run this code. So let's see what happens first. Okay. So sorry. I'm very sorry. I've left out the right part here. So this is supposed to be digital write of LED comma low. So you can go ahead and start the simulation.
So we can
So as
go
you can
ahead
see here, the
and
LED
run.
starts blinking. So now we can go ahead and change these delays if you want. You can play around, make it glow for slightly, make it off, make the LED be off for a slightly longer duration of time, and so on. You can play with it on your own. I hope this was fun and you learned something. I'll go over the code again just once more. Um, does anyone have any doubts in particular? Let me look at the chat once. Okay. Yeah, I'll go over the code once again. Let me repeat that once. Just a second. I'll just see if there are any questions that people have. Yeah, doubt and pin mode. Let me explain that again. Am I audible now? Can everyone raise their hands if I'm audible now? Yeah, okay, okay. Thank you, guys. Okay, let me repeat the code just once more. So this Arduino, this uses a slightly modified C++ code. So if we have begun by defining this variable LED, which we have set equal to 5. And then we go into the setup function, which is what is called when the program is begun. We have used the pin mode function. Then what the pin mode function does is it tells the microcontroller whether the pin we have defined here, which is pin 5, okay, as I've shown here. Okay, this is pin 5, by the way. It's marked here. This pin 5, we are telling the microcontroller that it's an output pin, and the microcontroller is supposed to give an output to it. That's what the pin mode does. And then we are going into the loop function. Since we want to blink the LED, we are asking the microcontroller to make the pin high and do keep it that way for a delay of the 1000 milliseconds, which is 1 second. And then we ask the microcontroller to make the pin low, and we again do so for a time of here I have given 1500, which is 1.5 seconds. So as you can see, the LED is slightly off for a longer time than it's on. So has everyone understood? Can I go ahead? Why int was assigned to value 5? So that's the data type. So if you have come across some programming before, you will see that this 5, it's an integer, and we have to define what kind of a variable 5 is. So since 5 is an integer, I have gone ahead and defined it as an integer. So this int represents integer. Uh, Someone has asked why code? Can't we just command it in English? So why code? I mean, that's because it's a computer. It really can't understand English directly, and the microcontroller is separate. And I hope you understand. So, are there any doubts? Okay. So, I hope you all understood how to blink an LED. In case anyone wants me to go over the code again, let me know. I'll do so. Um, All right, but so let's continue and go ahead with go quickly into sensors. Now, this part I'll be a little fast because the theory is not required too much here. We'll be starting with the simulation shortly, and I hope that'll be more fun and interesting to you. It'll be a little more hands-on as well. So I'll go ahead and present. I hope you all understood what was going on so far. In case you have any doubts, please let me know. Uh, So let me get started with what a sensor is. In case anyone has any idea of what a sensor is, please do put it in the chat box, all right? So does anyone know what a sensor is? It can be wrong. Put whatever you want in here. Show some enthu. I'll go ahead and start. So basically, a sensor is a device that detects and responds to any change in the sensor's physical environment. So here I have a capacitive and a photoelectric proximity sensor. These are just sensors which detect proximity, which is the closeness to something. So these sensors, they behave in a certain way, and I'll explain with some of the examples here. So here I have put up some different kinds of sensors. Uh, these are just pictures, and I hope, I mean, these sensors are what you'll be coming across in our various projects that we'll be showing you. So we'll get started with the first kind of sensor. So this is an ultrasonic distance sensor, HCSR04. So this sensor, this has 4 pins. Okay, I will be concerned with more about how the sensor actually works than, I mean, how to use the sensor rather than how it actually works. And these pins, which are what we use to communicate with the sensor, is what is important to us. So these 4 pins, as shown here, are VCC, trigger, echo, and ground. This trig represents trigger. Now, VCC and ground, they are to supply power to the sensor. You'll be coming across them in almost all electronic components you'll be dealing with. Uh, Now, this trigger and echo, these are specific to this sensor, and I'll explain what they do shortly. This is called the trigger input, and this is called the echo output. So, how does it work? The sensor, it's first triggered by setting the trigger pin to high. So, the trigger pin initially takes an input pulse of 10 microseconds. If we if we make the trigger pin high for 10 microseconds, the sensor will get activated, as shown here. That's what I'm saying. And then the sensor will be sending ultrasonic pulses at 40 kilohertz. These 40 kilohertz, 8 pulses will be sent from the sensor, and immediately the output pin, which is the echo pin, will go high, and the echo pin will remain high till the pulses hit some object and return back to the sensor so the sensor can detect. So I hope you can visualize how it works. The trigger pin is set to high for some time. Immediately, for some ultrasonic burst, ultrasonic pulses radiate from the sensor, and the echo pin goes high, and it will remain high till the waves get reflected from an object and come back. So the time duration and the width of the pulse, the time duration width of the pulse will be proportional to the time that is actually taken by sound to uh, go from this part to from the sensor to the object. Okay, so the way the calculation actually works, the way we'll be using it, we'll be demonstrating in the simulation later. So now let me go ahead and move to a different sensor. So for lack of time, we'll get back to this PAR sensor a little later today. Uh, you can see this meme. And I'll just explain quickly how a push button works. So this push button, I'm sure you have come across it many times. So this push button is basically something which is used to complete an electric circuit when pressed. This is pretty self-explanatory. It has 3 pins. It's a VCC, ground, and output. Now, when we ask what this pin is, this is also an output pin. I'll show you the way the push button is connected in the next slide. So as you can see here, when the push button is pressed, this connection is completed, and this VCC and ground is transmitted across the 2 terminals. Uh, so as you can see, when this is connected, it's like connecting VCC and ground together. They'll kind of get shorted, so we don't want that. Okay, so we generally insert a resistor in. So that resistor will prevent high currents from flowing into the sensor, and it's used to prevent shorting. That's it. So the way it's actually used, you'll learn in the simulation later. Uh, so when you this resistor is connected this way, and this pin is connected to an output which can be used for different various projects. So next we'll get started with the servo motor. Let me just go over it quickly. So servo motors are used when we want precise controller over how much the motor turns, till what angle it can rotate and such. The motor can rotate till a particular angle, and this is done using PWM signals, pulse width modulated signals, which I talked about earlier. the angle till which it rotates depends on the average voltage of the PWM signal. All right. So this is what I meant earlier when I said that the digital signal simulates an analog one. We can get precise control over the motor's function by using this idea of pulse width modulation. So we'll be learning more about this and how it works in the actual simulation part, which we'll be getting started with shortly. Now, just before we get started with the simulations again, I want to just introduce you to the serial monitor. So the serial monitor is very simple. It's an interface between the computer and the Arduino board that allows us to interact with the data sent by our Arduino board. So generally, this microcontroller is programmed by connecting it to a computer, and now the way it works is we have an IDE involved. Arduino, for example, has its own IDE, and we can write programs in the IDE to communicate with the microcontroller. I'll show what I mean shortly. So these are some of the commands you'll be coming across here. This begin off initializes the serial monitor, and this number A is a parameter called baud rate, which will be explained later. So this print off is to print the values, and print ln off is to print the value and then a new line, and so on. So just before we go, I'll show you how the serial monitor actually looks. As you can see in Tinkercad, we have the serial monitor sitting right here, and this is what receives and sends data to the Arduino, and you'll be seeing how we interact with it shortly. So we'll be working on our next simulations now. We'll be off to Tinkercad once more so that you can work with some more interesting simulations. Now, I'll just quickly go over this PIR sensor in a second. And in case you have any doubts, please let me know. You can put it in the chat box. So this passive infrared sensor is just a motion sensor. It works by detecting changes in heat patterns. As to how it works, we won't be worrying about it. As to how it is used, this output pin, which is the pin in the middle right here, it will provide an output signal of high. It will go high when there's a movement is detected. So if you move after connecting to VCC and ground, if there is some motion in front of the sensor within its range, that particular pin will go high. That can then be used for various applications like building a motion sensor and such. So the way that works is by detecting changes in infrared radiation emitted by surrounding objects and so on. That is not too important to us, but yeah, to get a basic idea, this is how it works. All the IR radiation is concentrated by a lens, focused by a lens onto some sensor, which will then produce an output. All right. So this is a fun meme that I found that I've put in here. And if you have any doubts, please do let me know. I'll try and see what I can answer. Amazing. A device that detects something and responds accordingly as you, yeah, it's amazing, guys. Can you repeat the meaning of digital right? Yeah, I'll just go ahead and do that before I hand over to Chandra for the simulations. Uh, digital right? Well, just a second. Yeah. So yeah, a digital write is just to set the pin to high or set the pin to low, set a digital pin to a particular value. We are telling the microcontroller, we are asking it to make the pin high for some particular time and make the pin low for some time by using the delay function here. We are just asking the microcontroller to make the pin into a particular digital value. That's it. I hope you understood. Uh, do we have any other doubts? Yeah, so yeah, I'm going to ask Chandra Bindu to take over for the simulations right now. Chandra is another coordinator for Elect Club, and yeah, he'll be demonstrating some fun simulations which you guys can actually work on, and I hope you all have a fun time. So yeah, Chandra, I think you can take over.
Hello, audible? Just in this audible or not? Limited, am I audible?
Yeah, you're audible, Chandra. Yeah.
Yeah, yeah. So let's start the simulation part. So I will be sharing my screen. Just a minute. Uh, is there screen is changing on the voice is increasing, right? Uh, just verify once. Hello.
Yeah, Chandra, your screen is visible. I think you can proceed.
And voice is also clear.
Come again. What?
Voice is also clear.
Uh,
Hello.
yeah, I can hear you now.
Okay. So let's start. Go to the create part in Tinkercad. Okay. Go to the circuits and it will open the design. Okay. Just search in Arduino. You will get an Arduino RT. Okay. And then just search breadboard. Yeah. Um, just any breadboard where you think this breadboard. It is good to use breadboard for a simulation. So we can make easy pixels and it will be very easy to debug and things in using in breadboard. So as you can see, the connectors are these five pins up and downs are connected together. You can see that some green dot visible there. So these five are connected together. These five are connected together, and this whole horizontal line are connected together too. And there is this negative sign and this positive sign, and also in down also. You can see that negative sign is there and positive sign is there. So these are connected horizontally. So what we can do, we start with ultrasonic sensor.
Hello,
So our
Chandra, can you hear me?
uh,
Your
uh,
audio is not clear right now. I mean, can you just speak a little bit clearly and maybe come closer to the mic or something? Slightly unclear. It's breaking in the middle. Is it audible, everyone?
now it is
Yeah, now it's slightly better. Uh,
now better.
yeah,
So,
if it's really not, if it's audible for everyone else, just please let me know in the chat box. Yeah, yeah. Someone has said it's not clear. I think you should speak closer to the mic.
it is not clear.
Yeah.
Not clear now.
Now it's slightly
Uh,
better.
better.
Can you
Hello.
speak a little bit louder? Can you speak a little bit louder?
Yeah,
Yeah, it's
yeah.
better now. Yeah.
Uh,
Speak a little louder
now
and
better, no?
yeah, now better, now better. Yeah, go
Uh,
ahead, go ahead. I'm sorry. Go
okay,
ahead.
so next, just use Arduino Uno in that you can do Arduino. Just search Arduino Uno RT, and you can bring it to the main page and also search Breadboard. And you will get Breadboard and just bring the breadboard also in. So what we are going to do, we are using ultrasonic sensor to measure the distance, and we are printing it in the serial monitor. So just look, select ultrasonic sensor here. Yes. So using this ultrasonic sensor, we said this one is just click it bring here in the main dragon. Okay, and here you can see that there are four pins, VPC, input and ground. So first, what we do, just connect the 5 volt of the Arduino Uno positive of the breadboard. This positive line. Connect. Connect ground pin at the Arduino with the negative port. Okay. And then what you do, connect the VCC of the ultrasonic sensor with the positive of the breadboard. Uh, yeah. Okay. And the ground pin with the ground. Yeah. So now what we can do, there is this trigger pin on this info pin. So connect the trigger pin with the four, just a minute. Yeah. So connect the trigger pin with this uh, four, this pin there. Connect it with the four and change the color. And then okay, connect with the second one. Just changing the color. Yeah. So connect it with the second pin. Yeah. So everybody is clear up to this. Uh, just raise your hands or anything. Everyone is clear up to this. Just raise your hand so we can proceed. Yeah. So now go to the code part. Everybody is fine. Or any questions, question we can or put in the chat. Okay. I'll try to be louder. So just go to the code. Okay. Uh, uh, just okay. So I will be here in the coding part. So just right. So first, what we are doing, we are defining variables. Okay, we are defining variables here, and we are defining the variables as constant variables. So we are writing constant in. So writing the thing then.
Chandra, hello.
Yeah.
Chandra, sorry to interrupt. Can you wait for some time? Give them some 2 minutes to
Uh, so
do
after
this part
we
and
are
then start the coding.
okay.
And also be a bit louder while speaking.
Yeah. Okay, so do like that. Please. So everybody is fine. Done this hardware part. Just confirm once. Hello. Uh, everybody is fine. So we can proceed for the coding part. Right? Shall we proceed? Hello.
Yeah, Chandra.
Yeah,
So,
Chandra, you can proceed now. Your voice is much better.
okay, so go to the code. So what we are doing, first we are declaring the variable. You know, declaring the variable constant. So const is the variable and then write the variable name. So we are writing trig for the trigger pin and do it put the equal sign and put the pin number and it is this trigger pin is connected with port port pin. So write port and also give the so then we are going to write the eco pin for the eco pin. Let's write the code const it okay and declare it and give it its P number and it is connected with the security. So uh, that is done. Okay. So what we can do next? Uh, go to the setup part and write. So you can say there here is the pin mode. So what the pin mode is, it connects the pin variable pin and it's right its mode this input mode actually is taking account. Okay, so for this that trigger pin is output pin because it is sending some signal. The echo pin it is taking so it is taking the echo pin and this input pin. So let's write the code. So we are writing the code in mode. Just give the the aim is capital. Okay, so write pin mode and write trigger. Okay, and declare it as output. Output. Okay, and then for the echo pin, we are writing as it is an input pin. So pin mode echo and input. Okay. So that's and for writing in the serial monitor. So what we are doing, we are writing this thing. I'm explaining during this time. I'm writing the code first. Serial dot begin and 9600. Okay. So what it does, it's this Arduino with our computer and it is doing interacting from Microcontroller sensor, then goes to it is coming to our monitor. Okay, so serial begin this 3600 is baud rate. The beats transferring second. Okay, so this serial begin 9600 is doing that. So this is about the setup part. So coming to the loop. So what we are going to do that just delete this code. Are you fine up to that? Just confirm on. Raise your hand or whatever you can. You can raise your hands. Okay, okay. So let's do it today. Then we can proceed for the loop part. Uh, okay. So as you know that this trigger pin and also the echo pin, they are transferring data as digital signal. So we are using that digital signal and digital for taking the digital inputs. So just write digital, right? Keep the W of the right as a capital and then trigger pin as low. So what we are going to do, as you seen in this, just a minute, increase this one. So In the this pin, you can see that the trigger pin will first making it low. Then for 10 seconds, we are making it high. Then again low. So we are doing the same thing in code. So just going to school. Yeah. So we are writing digital right trigger. Now we are waiting for some 2 microseconds. As in, as I saw, waiting for 2 microseconds. So write this code for waiting 2 microseconds. Yeah. This delay in microseconds. So the code is in microseconds and for 2 microseconds. Okay. Then digital write, digital write trigger, and now we are making it high. So yeah, this low you can you in caps lock, in big letters, and in this high also you write in capital letters. Okay. Then we are waiting for 10 microseconds. So delay microsecond. So we are using delay microsecond. No seconds. Uh, delay microseconds, and we are waiting for 10 microseconds. Then again we are making the trigger thing to low. So again we write delay digital write trigger low. Uh, digital write trigger pin as low. Okay, so we are send trigger pin signal. As you can see, it's low, then high, low. So the trigger part is done. Now what we can do, we are declaring some variables for our calculating purpose. So just write in the after the setup function, we write in duration that gives us the time duration. We are calculating in it in that loop. Okay. So in duration, and then another variable in distance. Uh, okay. So we are declared the variable, and now come to loop. So what we are doing, first we calculate the time duration. So I'm writing the code, then I will explain this code. Duration is equal to else in the string this function else in then echo and then I. Okay. So I think the up to that part it is clear. So how this duration does. So this function is on function this on function here. So it what it does, uh, uh, it calculate the time duration. Okay. Then write distance is equal to this duration, and then multiply it with 0.034 into divided by. So everybody is clear up to this. So what this distance does, it multiply the duration with 0.034 by 2. So I will be explaining this. Just tell okay or not. Just verify it is okay or not. Just tell. Is it okay? Just raise your hand. Uh, just confirm everybody. I'll be waiting for just. So after that, we'll do the printing part. So just confirm up to this. I'll be giving some time. Just do that. Okay. So after that, what we'll be doing? Just, am I audible? Audible now? Just confirm. Yeah, yeah. So now we are going to print. Till somebody is telling something. Yes, somebody is telling something.
Chandra.
Chandra, it is actually breaking
Yeah,
in
yeah, yeah.
between.
Okay, okay. Okay. Now it is okay. Now it is okay. Hello. Just verify once. So now it is okay, okay or not. Yeah, yeah. I'll be explain coding. Just
Yeah, it is
confirm my
bit
voice.
better now. Bit better.
Yeah, and if there is any fan running behind you, we can just turn off that. That is also interfering, I guess.
Okay, okay. So we proceed that coding part.
Yeah,
Just
now better.
let me write. Just let me write the code first. So after that, we'll discuss the coding. So what we are writing, we are printing text. So write serial dot print. So there is a two function on the print dot print serial dot print and another is print ln. So what that print does, it prints in one line and the print goes to the next line. So I'll be showing that also. So just write serial print and write distance. Then serial dot print. Next year you write the space of serial in capital letter. Otherwise it will create problem. And write the distance. Yeah. And then go to serial dot println. And the we are measuring distance in centimeter. So the unit has in centimeter. Okay. And that's the code. And make sure you delete at the last. So let's add the delete. Okay. and just this is not in this is false in yeah. So I'll be explaining on the question, but before that, this phone, okay, let's see, run this simulation. So yeah, the start simulation. Uh, okay, variable, declaring a variable for the trigger pin and the input pin. So as these pixels have pins, so we are looking at constant variables. So const into trigger pin is equal to 4, and we are connecting with the fourth pin in the Arduino Uno. And for echo pin with the second one. Okay, so this is the variable declaration. Then we declare two another variable for calculating purposes. Okay, so declaring two variables is duration and duration is calculating time duration and distance is calculating the distance. Okay, then coming to the points. So what it does, it so it's declaring two pin mode functions. So this connects the trigger pin. As we are getting, we are showing the output, we are giving the output from the trigger pin. So declaring this trigger pin as output. And so we are declaring it is input. This coming to the serial. So what it does, it connects the Arduino with the with computer, so that the data transfer happens, and the data transfer happens in a 9600 baud rate. So it is on the common baud rate we are using in Arduino. Okay, so there are various baud rates. So we are using 9600. Okay, so everybody is clear up to there, up to second part. Everybody is clear up to there. No, am I audible? No, am I audible now?
Yeah, you
Yeah,
are audible.
right now you're audible.
No, am
Yeah,
I
Chandra,
audible
you
now?
are. Yeah, you are audible,
Yeah.
but breaking in
So,
between. Your voice is breaking in between. So yeah, people ask some doubts in chat.
okay, okay. Just a minute. Uh, so, just sharing the screen. Just a minute. Yeah. So, in the serial the begin what we are doing, we are connecting the Arduino with our computer or PC, whatever it is, and it is doing data transfer. So what it does, it takes the data from uh, Arduino monitor. So the calculating everything is done in the Arduino, and then it sends the data for printing the data in our computer. So in this case, using simulator. So for real Arduino, it is happening like that. So it connects the Arduino with our computer, and the sensor transfer is happening. So that is 9600 is the baud rate. The serial bit. And in this loop part, what we are doing, we are printing. So there are these two functions, serial dot print and serial dot print ln. So print ln what it does, it prints on new line and printing this in this case it is printing the semi and then comes to the new line part. Okay. So that's the serial part is happening. Now it is clear. Just confirm once. Uh, just confirm once. Uh, just confirm. It is now clear. The serial. I need to. Verify once. Do this silent.
Guys, can you just give us a minute? Yeah, we will try to explain it again. Just give us a minute.
So it is okay now. Just raise your hand. Okay. The serial part is okay. Uh, so we are running. Yeah. So shall we proceed? All are okay with serial part. Just confirm one. Hello. So just here the question is start simulation button. Okay. Select the code. You can see if it is working or not. Open the serial monitor. So you can see that this is printing the distance here. Just a minute. Continue this. You can see this is giving us the value of the distance in centimeters. Now you can check. So it is giving us the value. So uh, any clarifications or any questions? Just ask. You can put it in the chat.
Chandra,
Yeah, yeah.
can you just
Hello.
show the code? I will just explain it once so everybody can understand that ultrasonic code. Can you
Yeah,
show the Tinkercad from first interface?
yeah,
So guys, basically what we are trying to do here is to measure the object distance. So yeah, so basically ultrasonic sensor produces ultrasonic sound. It goes and ultrasonic waves. So it will the trigger pin will send ultrasonic waves, and it will go and hit an object and gets reflected back, and pulse pin echo pin will receive it. So this is how it works. So first what we are doing is that we are defining the trigger pins and echo pins, and then we are defining some variables, duration, and assigning them, they are integers, so we are just giving them int duration and yeah, int distance. So in void setup is the code where we will be assigning the pins as whether input or output, and this is a part of the code where it will be run only once. So in this case, as you can see, trigger pin will be sending the ultrasonic waves. It will be the output. It will be assigned as output, and echo pin needs to receive the reflected waves and send that as an input to the microcontroller. So they will be assigned as the input. So as you can see, pin mode is used for that, and pin mode trigger pin, it is output, and pin mode echo pin is input. So this serial dot begin, so this is basically used for starting the serial monitor. So serial monitor is a device which is used as an interface between the users as well as the microcontroller board. So this can be used for getting any input information from user, or for displaying some output. So serial dot begin of 9600. Yeah, this 9600 is the baud rate. So baud rate is basically the rate of data transmission. So the number of bits traveled per seconds. So this next coming to void loop. So void loop is basically the code where where this part of the code will be run multiple times. It will keep on running. So yeah, so here you can see digital write. Digital write is used for assigning some variable pins. I mean, for assigning some pins as high or low. In this case, you can see trigger pin will be assigned low for 2 microseconds. So as you can see, the next line delay microseconds 2. So 2 is the number of microseconds it has been kept low. And then it is turned high for 10 microseconds, and then again turned low. So this is basically like a kind of rectangular pulse, and this is a single rectangular pulse. As this is in void loop, this will be sent multiple times. So this will be a series of pulse. And then next, coming to the next line, here you can see about this duration and distance variable. So this is the pulse. There is a function called pulsein. So what does this pulsein does is that it gives us the time, amount of time for which the echo pin remains high. So basically you can see that inside the parenthesis there are two parameters like echo and I. So this signifies that the amount of time for which the echo pin has been high. This will return that value. So pulsein function basically returns the amount of time for which the echo pin has been high. So as you know, you can calculate the distance using speed and time relation. Speed and time relation. You can use that formula to get this distance. So if you consider speed of the sound to be 340 and distance to be 2D, as it is going once and getting reflected, and speed is equals to 2D by t, with that you can get the distance. So then what we are doing is that serial dot print of distance. So basically we are printing distance, and then as we found out the distance using this formula, it will get printed, and then Yeah, next the centimeter, and this serial dot print ln. So what does it does is that it will print in the next line. So these all three will be distance in the strings, then the value of the distance which is calculated, space centimeter. So all these will be printed in single line, and then the next will be printed in the next line. So and this delay of 1000 is delaying it by 1 second. So after 1 second, this code will be repeated. So as when he starts simulation and then moves the object, here in the serial monitor you could able to see the distance of the object. So is there any doubts? You can put it in chat, we will clear. Is it clear or any part need to be repeated? Yeah, if it is clear, I think Sriniket can start doing PIR.
Hey guys, hello again. So now I'll be demonstrating how to use a PIR sensor. So just before we get started, I'll explain how the PIR sensor works. Okay, just a second. Let me share my screen. Yeah, I will explain the formula required to calculate distance. Okay, just give me some time. Okay. Yeah, can you all see my screen now? Oh, okay. I don't think it's visible. Is my screen visible now? Can you guys just raise hands to let me know?
Yes, it is visible.
Okay.
Now it is visible.
Yeah. Okay. Okay. Now it's visible, right? So okay. So let's get started, guys. So so I'll just explain how this PIR actually works since I didn't do it justice in doing the first part. So the PIR sensor is called a passive infrared sensor. Okay, so the function is to detect change, basically it is used to detect motion, and the way it does that is by detecting changes in infrared radiation. So when an object when an object moves, generally you will find that there will be a change in infrared radiation because different objects emit infrared radiation in different levels, and in this case, the PIR sensor has a lens which focuses the IR radiation onto a sensor, and that sensor is actually what we call a pyroelectric material. So basically it responds to it produces an electric current when there is a change in temperature, which is basically IR radiation. So the way it works is for a particular IR radiation, there will initially be some current, and then the current will then go off to zero as long as that radiation is constant. So if the radiation suddenly changes, there will be a quick current once again, and when the stable value of the radiation is read once more by the sensor will the material will no longer discharge a current, and the sensor value will read zero. So that tiny current generated by the material is actually amplified using an amplifier, which is then used to read a high value. Let me just check if there are any doubts. So if you have any doubts regarding my explanation so far, please do put that in. Uh, yeah, let me just check the chat once more. By the way, is my audio clear? I hope we're not facing any audio issues now. Is my audio clear? Can someone just put it in the chat? Yeah, okay, thank you, thank you. Thanks a lot. Yeah, so I'll just get started with the actual simulation. So once again, we head into Tinkercad. We can go create a circuit as shown here. And just a second, guys. I'll just, yeah, okay. So we'll be using this PIR sensor. It's available in Arduino. You can go into components, go into search, and PIR sensor. So a quick search should give you this. So this is the PIR sensor. Uh, Now hovering over it, you can see that this pin is the ground, this pin is the power, and this pin is the signal. Okay, so power is again basically just VCC. So this pin right here is what will actually detect the motion. So once again, we'll be needing an Arduino microcontroller. So let me go and pull that up as well. So Arduino Uno R3 is what we'll be using again, as I said earlier. Okay. So how do we connect this? So now this pin is the signal. We'll leave it for later. So this pin is power. Okay. So this microcontroller, this has a power section, right? So this part is actually, I mean, I hope you can see my mouse cursor. This part right here. This is what was used to program a microcontroller, and this part here can be used to deliver power to the circuit. Okay. So that is what they mean when they say power here. I'm hoping that's clear now. So here, right here, we want a 5-volt power supply, which is what we generally use for VCC. But yeah, we have pins here for 3.3 volts as well. But we'll go ahead and use 5 volts, and let me use a green color right here for 5 volts with my convention, which I stuck with earlier. And let me go ahead and connect it to power. So now this will deliver power to the IR sensor as well. The microcontroller will deliver 5-volt power supply, but in order to complete the power supply, we obviously need to ground it, and we have 2 ground pins right here. So let me go ahead, pull this up, and let's yeah, I think we'll, yeah, just a second. Can do a click here. We can move it right here below the ground, and yeah, connect it to the ground. This wire will make it black, as a usual convention dictates. So now we have a passive infrared sensor powered up. So now we want to read the signal. So I'll go ahead, take a wire here, um, and connect it to one of these pins here. Say, let's say 10. Uh, yeah, let me make that nice and straight. And we can change the color here back to, let's say, green. Yeah, so this interface and all, I'm hoping it's reasonably clear, all this color and all. So yeah, our basic setup is done. We don't need anything more here to make the IR sensor work. So let's go ahead and get started with the code. As usual, let me go ahead and change it to text. Uh, okay, so we'll slightly go ahead, back this up, and let me begin. So as earlier, I'll begin by defining a variable here so that a job becomes easier if we need to change values later on in larger circuits. It's a good idea to stick with the practice of using variables for numbers so that any change will reflect across the whole thing. And I'll say, I'll call it PIR sensor, and let me mark it as 10. Okay, so our variable here is defined, and I'll go ahead and initiate my void setup off, and the curly brackets right here. So I'm hoping till this part, I hope you're fine. I discussed the void setup part when I was discussing how to blink an LED. The setup is used to initiate the program. Let me explain the code as I write it here, and I'll go over it once more. Uh, just before I proceed, let me check if there are any doubts so far. Just a second, guys. Yeah, hopefully everything is going well. And yeah, let me continue. Okay, so the void setup of, remember, the first thing we need to do when we use a microcontroller is to describe what pin we are going to be using. And to do that, we call upon a trusted pin mode function. And yeah, I can again use the number 10 here, but I'm going to go ahead and choose to write PIR sensor. This PIR sensor just tells the microcontroller that there's a value 10. We're just assigning the variable to that number and using the variable instead of the number, so that the microcontroller knows you're talking about. And see, so the thing is, this pin right here, now it's going to be treated as an input pin. Why? Because we are going to be using our serial monitor to read the output here. Okay, now let me explain that once more since it's not clear. I'm going to go ahead and mark it as an input pin, because the PIR sensor, which is used to detect motion, provides input to the microcontroller. So if I go click onto this, I'll be able to show simulate things moving in a second. When I run the code, you'll see that. Just hang on till then. Uh, so this PIR sensor, when it detects motion, that it will tell the microcontroller that some motion is being detected. So we call that. So that's why we call the signal pin as an input pin here, and the microcontroller will then communicate with the serial monitor, letting us know that there has been some motion. So the pin mode of I hope everyone is clear with now. And to initiate the serial monitor, I have to go ahead and give a serial.begin here as well, and a trust-free baud rate of 9600. Now, I saw some questions earlier regarding why this number is 9600. It's just a standard number, and we really don't need any higher numbers beyond that. Okay, if we communicate too fast, too much noise will tend to creep in, and if you communicate too slowly, you'll find that the communication is generally not fast enough. So this number, it's kind of a good balance between other numbers to, anything in this range is fine. This number is generally used by electronics engineers to use microcontrollers, so we prefer this. That's all. We're just sticking with convention here. There's nothing special about this number. It's just a convention. So let me finish the setup of function here. Now I need to go ahead and initiate void loop of, because I want to keep the program running. I want the microcontroller to keep working. So this thing needs to keep running again and again and again, because we are not going to stop with one detection. We need to detect occurs. So we need a loop function to write the part of the program which is going to keep running. All right. I hope everyone is with me so far. If there are any doubts, let me know. I'll take a look once again at the end. So I'm going to initiate the void loop of command here, which you all know what it does. And I'm going to open our curly brackets, which is describing this. I'm hoping no one is having any trouble following so far. So here, well, I'm just defining another variable. I could have done this earlier as well. You'll see why I'm doing this shortly. I'll just explain as I go. So let me just go ahead and define in digital signal. Let me spell it right. Digital signal equal to, and we have a trusty digital read function. I hope you remember I mentioned this earlier. So what does this digital read function do? By the way, it accepts only one parameter here, as you can see. And this digital read function will just tell me the value of the pin number 10 as which is written here at a particular time. All right. So I'll move on to the next statement. Here, this is also simple. Those of you who have had exposure to programming will know of an if condition. So let me put the if thing here. So if digital signal equals high, I'm going to detect motion. So what will I do? I'm going to go ahead and do a serial dot print. I want to print on a new line every time motion is detected. So I'll do serial dot println of detected. I mean, I'm just writing detected here for me to, detect motion whenever it occurs. You could go ahead and write something else as well. And let me finish the if statement here. Okay. So the next thing we are going to do is, now remember, this loop function is going to keep running continuously. Okay. So when I introduce some kind of a motion, there needs to be some delay so that I don't keep detecting the same, I don't keep printing detected for the same motion. So this delay is generally dependent on the use case. I'm going to go ahead and introduce a delay of 2 seconds here. I hope you remember this 2000 is because the delay parameter accepts the input in, I mean, the parameter is monitor is in microseconds. So sorry, milliseconds. I'm very sorry. It's in milliseconds. So I need to give 2000 to introduce a delay of 2 seconds. So that really completes this program. Remember, I have introduced this delay here because when I detect a motion, this loop is going to keep running. Okay, I want a delay. I want the loop to take a delay for 2 seconds because I don't want the uh, serial monitor to print detected too many times for the same motion. That doesn't serve its purpose, right? So we go ahead and introduce this delay, which is dependent on the use case. For the demo, for this demonstration, I'm going to introduce a delay of 2 seconds, and I think this completes our program. Hopefully, it will work. Let me just check again if I have made any mistakes. I don't think so. So let's go ahead and start. So the starts, I think this is going to work fine. So we have our serial monitor pulled up here, and if I go ahead and choose to move it, you can see that we get our output of detected. So this simulation works this way. I mean, this is the object. So when this object moves, we are able to see that the motion which is detected gets printed here. So this is basically how a motion sensor works. Okay, this is the simple basic code which allows us to detect moving objects. So I mean, this object is I'm just controlling this object here for demonstration purposes. I'm hoping you can understand that. And I mean, generally, when an object moves in front of a PAR sensor within this range, it is going to detect that motion. And if we have an Arduino hooked up to the computer, we're going to get this output of detected. Okay, we can print something else as well. And note that since I have given this delay of 2 seconds, I'm able to get only one output for this one particular motion. So this code is right now working fine. So I'll explain this once more. I'll just check to see if you have any doubts. If you have any doubts, please do let me know. I'll just check the chat once. So is everyone clear with this explanation of the PIR sensor? Are there any doubts? Yeah, we can blink an LED if it is detected. That shouldn't be too hard. But yeah, that's not for today due to time constraints. But yeah, you can go ahead, research it up. Should be fairly straightforward. You can blink an LED. Yeah, I mean, the 10th pin is random. We can go ahead with any other pin. Till what range does this sensor work? That is dependent on the sensor. You can go ahead and check it up. Right now, I mean, that's a fairly straightforward question. You can go ahead and check it. How does the computer know how many loops to execute? Uh, I mean, we are telling the computer, all right, this loop function, this is not really something, I mean, here, it's not really something that is number specific. This computer is just going to keep executing this loop till I go ahead and stop the simulation here. So this loop is going to keep running, and that's what we want in use cases, right? We don't want the motion sensor to suddenly stop working if the loop is over. We want the whenever we turn the motion sensor on, we want to detect whatever motion is observed. So that's why so the computer really doesn't know how many loops to execute. It just keeps executing till we tell it to stop. How to see the output? I'm hoping that you can now see the output. It's by clicking on the serial monitor here in Tinkercad. In the actual Arduino IDE, which is what you'll probably be using in case you are playing about with actual hardware, you will find the serial monitor there. That's also straightforward. Serial communication is between which two devices? Okay, serial communication is between the Arduino and this and this IDE. Uh, this environment that I'm writing that I'm programming on to and using to communicating with the Arduino. That serial communication, it is between this Arduino and this IDE that I'm working on. IDE is an integrated development environment, which is what I'm writing the program in. And both of these, basically, it's my computer. I'm using my computer to communicate with the Arduino, and the baud rate describes the rate of communication between these two devices. The serial monitor kind of acts as a middleman between the two, and we can see whatever we want to print as input output that we can uh, print. So yeah, let me just explain the distance part once. So I'll since many people are asking, I'm hoping it's clear, but I will do it once again. I mean, does anyone need me to do it once more? Yeah, can you guys just let me know in the chat? Uh, so guys, does anyone have any doubts they'd like me to address? Any particular doubts? Or shall I just go over the code once again, just for completion? I know that for some of you this may be completely new, and since this is an introductory session, I want to make sure that you're clear with all this before we go into tomorrow's, or I mean not tomorrow, the next session. Okay, do let me know if there is anything you need help with in the chat. I'll just go ahead and explain the code once more. So I'll do this carefully. I hope you understand. So first I've begun by initializing this variable called PIR sensor. Now this is generally done in programming languages like C, C++. And since Arduino uses the same kind of thing, I am declaring this PIR sensor variable to be an integer only because I want it to be an integer. I could go ahead and why not? I'll just show you. This PIR sensor, let me change it to 10. You'll see that the program has no change in it. So if I start the simulation here, you will find that the same thing happens. So you can go ahead and clear in case you're not convinced. Uh, yeah, just a second. If I move this around, oh, I mean, I went outside the range, I guess. Yeah. So you can go ahead. If I move this around, you can see that detector is printed. And you can see that there's a 2-second delay as well, by the way, this thing. I hope it was interesting. So yeah, so the variable, it's not really, but we do prefer to do it because in larger programs, it becomes easier to, debug and all that. So I'll go ahead and stick with PAR sensor. Yeah, I spelled it right. So the spin mode, this is used to recognize the spin number 10 as input. Yeah, which is completely random as someone mentioned. We can use other pins. The serial dot begin off is to initialize the serial monitor for communication between the Arduino microcontroller and the computer. So we need to tell the microcontroller that, hey, I'm going to be communicating, the computer is going to be communicating with you. So yeah, please be available, something like that. This loop function is going to keep running because we want to detect motion whenever it happens. Okay, so this digital signal, I'm initializing a variable. So I could just go ahead and say if digital, instead of digital signal, if digital read of 10 is high, but I prefer not to do that. I prefer to keep my variables separate so that it becomes easier to see where the mistakes are if you do write a program that may generate some error. The serial.println of prints the word and a new line. So I am using the word detected to just show that whenever there is a motion, the word detected can be printed. And then we are introducing a 2-second delay. We can make this delay shorter. Generally, I think it's a good idea to keep it shorter. Maybe 1 second is sufficient to demo. Yeah, I hope you understand. I'll just check again. Does anyone have any doubts? Please do let me know. I'll check the Q&A once more. Why use digital? Okay, someone has asked what is digital read. Let me go into the presentation. I thought I had explained this earlier. I'll explain the basic command. I'll quickly go over the basic commands in the little time that we have. The spin mode of function, I'm hoping everyone is clear now, is used to tell the microcontroller whether that particular pin is going to be used as an input or output pin. The second function, digital write-off, is used to set a pin to a particular digital value. I mean, you can change the pin according to digital write. You're telling the microcontroller that this output pin is to be of this value in this particular use case. That's all digital write is. Digital read-off is used to read the value from a specific digital pin. So if you have a digital pin which you are using as an input, you need to use the input value available to you, right? It is not sufficient to just say that such a pin is an input pin. You are supposed to, I'll come to the other questions later. You are supposed to, uh, I'm sorry, you're supposed to read the value from the given digital pin, right? You need to use the value, and in order to do so, you have to read it. So as like in any computer program, you need to use it to do so, and that's
It is
why
not
digital read is
sufficient to
used.
just
I'm
say that.
hoping that's fairly straightforward. I'll also go and do the final few commands once again, the serial monitor commands. Uh, I think I should probably present it. Okay, the serial. I'm hoping what the serial monitor is pretty clear to everyone. So the serial.begin of function is used to initiate the serial monitor, and the A is a parameter called a baud rate, which is the rate of communication. Serial.print of prints the value. Serial.print off prints the value and then takes the cursor to a new line. The serial.read of function, which used in the program, is used to take the input of the incoming data. Okay, you don't need to be too worried about that for this program. So we'll go ahead and do it here. Well, I'm hoping the program is clear. The next question. Okay. Why use digital signal equals digital read? Yeah, I explained it earlier, and I'm hoping it's clear. I'm just we don't need to use it, but see, if we generally declare variables for read and for the pins in general, it is going to be useful to debug and all. So if when you write a large program and you're using digital read of multiple times, you're not going to be able to find out where the error is that easily. So you're using that pin. That's all there is to it. Why delay is used? Is it for the sensor for the detection? Yes, it is for the detection. The delay is used because you're asking the loop to wait for a specified amount of time before it's run again. We don't want to detect the same motion too many times, right? Because you see, if I make this, let me just demonstrate that if that's a question. If I make this delay something very short, like let's say 100, it is going to be detecting the same motion multiple times. Let me clear the monitor as well. Uh, yeah. So you can see you can see what's happening. So for just one motion, detector is printed multiple times, which I personally don't want. So we are introducing a slightly higher delay in order to make sure that the motion is detected the way we want it to. The motion will still be detected, except we'll get detected printed many more number of time, which becomes very confusing to us. So that's why it's being used this way. So I'm hoping everyone understood this program. Really sorry for the technical glitch earlier, guys. That wasn't intended to happen, and I'm hoping that doesn't demotivate you from coming to further sessions. We have many more things planned for the future sessions, and I'm hoping you'll find them all very interesting. So this task, we will get back to you later on this. We'll communicate with you over the WhatsApp channel or the Teams group. I know that some of you are facing some issues, so you can reach out to us. We'll try and address them, address any issues that you might possibly face. I'm hoping you all had fun in today's session and you learned something. Um, and yeah, uh, that's it for today. Thank you all for coming to the session. We will be circulating a feedback form. Please do fill it, and we'll try to ensure that such problems don't come up again. Uh, Really sorry for the inconvenience that this may have caused. Uh, that's it, guys. That's it for today.
Yeah,
I'm hoping you learned some. Yeah,
uh,
I'll let Pranesh
yeah,
take over.
yeah. And people, I'll talk about the certificate eligibility criterion that we have set. Like we'll post the task for this session like in an hour or so in the group, and we'll give you some enough time to do it, and we'll float a GPOM to submit the task. So it will be a small simulation kind of task, and we'll consider attendance for all the sessions that you have attended and the task you have submitted. So you're supposed to submit the tasks and get it evaluated, and then we'll see the attendance. We have downloaded the attendance report now, and we'll see who have stayed throughout the session, and we'll take that as attendance. And this is the certificate criteria that we have set. And yeah, that's it, guys. We'll float a feedback form, and you guys do say if you have any feedback regarding the session. and what all can we improve? Oh yeah, okay. We'll look into it and we'll create a forum for discussion as well as soon as possible. And regarding the chat box, many people who have joined through the link that you sent through channel, you might not be able to access the chat box because you are not in team. So make sure that you have the MS Teams account with the mail that you have registered through CFACE website. So our team have sent invite links to all of you people. So if you have created an account, then you will surely join the team and you will have the chat box. If not, if the problem sustains, then you can use the Q&A section for doubts. We are clearing actively there as well. No, we'll share a new link every day for that. So don't worry. Okay, then we'll send a G form to get the problems regarding teams like who all have account but didn't get added. We'll give it to the manager team and we'll take care of it.